When you're going up on a heating and cooling graph, the particles become less dense and spread further apart. If you start with a solid and go to a liquid, you're going to go through the melting phase. Your substance remains at a constant temperature during melting. An example of melting is the ice cube melting on a hot summer day. When you go from a liquid to a gas, you go through boiling. It's going to remain at a constant temperature during boiling because it's trying to convert all the particles. And an example of boiling is a water boiling in a pot. When you go from a gas to a plasma, you go through ionization. A plasma is like lightning and fire, and it also remains at a constant temperature during ionization. If you're going straight from a solid to a gas, it is called sublimation. It skips the liquid phase. An example of this is dry ice because it's able to go from a solid to a gas without being a liquid.
Okay, going down on the heating and cooling graph, starting with plasma. From a plasma to a gas is called deionization. That stays at a constant temperature. From a gas to a liquid is called condensation. For example, the slick wet surface on the glass that you get when you put a cold drink into a room temperature room. And then from a liquid to a solid is called freezing. For example, when you put water in an ice cube tray and then you put it in a freezer and it becomes a solid ice cube. And when you go down on the heating and cooling graph, the particles become more dense and the particles become closer together. And when you go from a gas to a solid, that's called deposition, which completely skips the liquid state. Ice is a solid where the particles are vibrating in their fixed position with low kinetic energy.
When ice melts, it becomes a liquid, and the particles slide and glide past each other. It has a higher kinetic energy than a solid.
Condensation is the transition from a gas to a liquid where the kinetic energy is going down.
Boiling occurs when a liquid is transitioning to a gas. The temperature remains constant as the particles are changing over, and it will continue to rise when all the particles have changed over. The kinetic energy goes up when it becomes a gas. For this experiment, you would use a pipette instead of a teaspoon.
In this experiment, we would use a graduated cylinder instead of a shot glass because it gives you measurements and is more precise than a beaker.
For this experiment, you would use beakers instead of bowls because it gives you measurements so you can measure ingredients a little bit better.
Safety glasses should be worn at all times for eye protection, and long hair must be tied up with a hair tie. Ain't that nice?
The hypothesis for this experiment was the pasta will turn green because it was soaked up with the water with the green food coloring in it.
The control was our past knowledge of pasta making. We are using the same water in the same pasta as we have been when making normal pasta, as well as the amount of time cooked.
If you were to measure the water in food coloring, the amount of pasta, and the amount of time cooked, this would be considered quantitative data.
Both the pasta and the water are green, as well as the food coloring. This is qualitative data.
Some safety concerns, and we were very careful about not burning ourselves.
The independent variable was the green food coloring.
And the dependent variable was the green pasta.
The conclusion was the pasta did turn green for this experiment.
Errors, nothing was measured in this experiment.
Chemical reaction was the pasta was being cooked. It is no longer the same as it was before. It was hard and crunchy, but now it's soft and chewy.
The physical change was the pasta is green. Turning green did not change the chemical makeup of the pasta because we just added coloring to it.